part of the program in the series of database management system. The topic of our discussion is the relational model. The objectives are the concept of domain, the meaning of the term relation, properties of the relation, and Court's rules. First of all, let us see the definition of domain. A domain is a set of permissible values for a particular attribute. Let us understand this statement with an example. This is an example of the supplier's relation. It consists of three attributes: S-name, status, and city. For the attribute S-name, the domain is the set of all the names, and similarly for the case of city, the domain is the set of all the city names. A domain can be defined to be a named set of scalar values. Now, what is a scalar value? A scalar value is a smallest semantic unit of data in the sense that they are atomic. Now, what are atomic values? Atomic values are those values which are non-decomposable. That means you cannot divide nor decompose those values further. Let us understand the concept of atomic values with this example. This is an example of parts relation. It consists of three attributes: part number, part names, and the city. All the values of part number and the names and city, these are non-decomposable values. That means you cannot divide nor decompose these values further. That's why these values are known as atomic values. To create a new domain, the command is create domain, domain name, and data type. Create domain is the syntax. Domain name, you have to give the particular domain name which you want to create, and you have to give the data type of that domain. Create domain will cause the DBMS to make a new entry in the catalog to describe that new domain. Now, the following assumptions are made for creating the domain. The first assumption is this: domains have names that are unique within the database. And the second assumption is this: named relations have unique names within the database. That means when you are going to create the domain and the relation, you have to take care of that all the domain names and the relations should be distinct names. The attributes have names that are unique within the content relation. Now we will see the examples for creating domain. This is an example, that is create domain S-name char 20. This create domain is the syntax, S-name is the domain name, char is the type of the data, that is character data type, 20 is the width of the data. To destroy the domain, the command is destroy domain and the domain name. Now we will have the concept of relation. A relation R consists of a heading and a body. A heading consists of a fixed set of attributes, or more precisely we can say the attribute name and the domain name pairs. That means we can describe like this: the A1 is the first attribute and it has the domain D1. That means this is your first attribute and this is the domain of this first attribute. Similarly, it can consist of the second attribute and the second domain. Just like this, you can have a number of attributes, for example, n number of attributes, and Dn is the domain name of the nth attribute. The body consists of a set of tuples. Each tuple in turn consists of the attribute name and the attribute value. That is, the body consists of the attribute name, that is, this is your first attribute, and the value of the first attribute, that is your vi1. Similarly, this is your second attribute, and the value of the second attribute is vi2. Similarly, the nth attribute and the value of the nth attribute, where this I is the range between 1 to m, where m is the number of the tuples. To create a relation, the command is create relation, that is your syntax. Relation name, you have to give the relation name. Then within the bracket, we can give the attribute definition comma list, candidate key definition list, and foreign key definition list. This is an example. Create relation. S is the relation name. S name is the first attribute. It has come from the domain S name. Status is the second attribute. It has come from the domain status. City is the third attribute. It has come from the domain city. Now to destroy a relation, the command is destroy relation and relation name. Now we will see the properties of relation. First property of the relation is there are no duplicate tuples. That means all the tuples within the relation should be distinct. Next property is tuples are unordered. Since the body of a relation is just like as a mathematical set, and we know mathematical sets are unordered, that's why we can say the tuples are unordered. For the similar reasons, we can say the attributes are unordered. And next property is this: all attribute values should be atomic. Next we will see the relations and predicates. Let us consider the statement: the supplier with the specified name and the specified status located in the specified city. This statement is an example of predicate. Now what is a predicate? Predicate is a truth valued function, a function of 3 arguments in this particular case. The substitution S name is equal to Paul, status equal to 20, city is equal to Delhi yields a proposition that is true. But the substitution S name equal to Amit, status equal to 15, and city equal to Kolkata yields a proposition that is false. Basically, what is important is this: a relation always consists of exactly those tuples that make the predicate evaluate to true at that time. Next we will get the concept of Codd's rules. In 1985, Codd has proposed 12 distinctive rules by which a database can be described how relational it is. The first rule says all information in a relational database is represented explicitly at the logical level and in exactly one way by values in tables. Second rule says null values are supported in a fully relational DBMS for representing missing information in a systematic way. That means when you will do the data entry in the database, If you have any missing information, you can represent that missing information with the help of null value. The database description is represented at the logical level in the same way as ordinary data, so that authorized users can apply the same relational language to its interrogation. That means users and programmers need only know only one language, for example SQL, that we call as structured query language, to describe the complete database. Next rule says each and every datum in a relational database is guaranteed to be logically accessible by resorting to a combination of table name, primary key value and column value. There must be one language that is comprehensive in supporting all the following items: data definition, view definition, data manipulation, integrity constraints, authorization and transaction boundaries. Next rule says all views that are theoretically updatable are also updatable by the system. The capability of handling a base relation or a derived relation as a single operand applies not only to the retrieval of data but also to the insertion, updation or deletion of data. Application programs and terminal activities remain logically unimpaired wherever any changes are made in either storage representation or access method. Next rule says application programs and terminal activities remain logically unimpaired when information preserving changes of any kind that theoretically permit unimpairment are made to the base tables. Integrity constraints specific to a particular relational database must be definable in the relational data sublanguage and stored in the catalog, not in the application programs. A relational DBMS has distribution independence. If a relational system has a low-level language, that low-level language cannot be used to subvert or bypass the integrity rules and constraints expressed in higher-level relational language. That means you can use low-level language in a relational system. For example, C, Fortran, Pascal. But you have to take care of, if you use the low-level language also, you cannot violate or bypass the integrity rules or the constraints. In this session, I hope you have understood the concept of domain, the concept of relation, and the properties of relation and course rules. Thank you.